Next, we are going to study about the which one? Non-vector interrupt. This is very important actually, non-vector interrupt. Non-vector interrupt. Okay, now how non-vector interrupt works? See, so microprocessor 8085. So vector are trap 7.5, 6.5, 5.5. It is only I write the here is a INTR. Okay, the all four we know. Okay, what the first one? Trap RST 7.5, RST 6.5, RST 5.5. So what is the difference between the vector and non-vector? So you know the every single device, device 1, okay, device 1, the device 2, device 3, device 4. Some device no, maybe can assumption keyboard or smoke detector sensor, something, whatever, mouse, touch screen, whatever. Okay, here 4 devices are there. Okay, so what happens? The how many number of devices are there? Yeah, that number of interrupt lines are required if you go to this method. Okay, because why? Because every device have one fixed location or not. For keypad interrupt, we have a predefined keypad interrupt handler. Okay, 4.5 location, 7.5 is a mouse interrupt, 6.5 everyone have vector addresses or not? Fixed address will be there. Okay, so for example, your laptop around 30-40 devices are there, on interrupt handlers are there. So now what happens if you go this method? So how many number of devices are there? That number of pins required. That number of pins required. If you go this mechanism, the how many number of devices? Okay, so if you go this mechanism, how many number of devices is equivalent to so number of the interrupt lines. Number of what? Interrupt lines. So the pins only. The interrupt lines are pins are not. No. For example, 30, 30-40 are there easily our laptop. Okay, 30-40 pins required. Understood? That number of pins are required or not? No. Interrupt handler. Okay. So this is the drawback actually. This also you can pronounce like a single device, single interrupt line. The methodology. Okay. This is not a drawback actually. No. Single device, single interrupt line. Every device have an interrupt line or not? No. This is a method no. Okay. Now the vector interrupt follow this method actually. Vector interrupt the methodology this one only. Vector interrupt the method. That's why vector interrupt not good actually. See. So everybody, every interrupt have one predefined address nothing but the micro is not good actually because 30 lines increasing or not no. So what happened? Tell me more number of pins increasing. Okay, pin size increasing, size of is increasing only. But that is not a matter. The main problem is whenever number of pins are increasing, microprocessor side more complexity happen only. Okay, actually what a microprocessor job? Actually, microprocessor job always execution of a instruction. That is actual microprocessor job only. Yes or no? Microprocessor execution of a task. Microprocessor communicate the memory, load the what? Instruction. The main goal of the microprocessor execution of a instruction. But if you increase the number of pins, apart from execution of the instruction, microprocessor responsibility to extra information adding or not? No. What happened? Tell me, if you increase the number of pins, what happened? Obviously, first thing, priority come in the picture. This is come in the picture, priority. For example, 30 pins are there only. Out of 30, suddenly 2 interrupts occur same moment only. Then microprocessor responsibility find out which is the high priority. Microprocessor external unnecessary job more. Actual task was execution of instruction. Unnecessarily microprocessor find out like which interrupt higher, which interrupt lower. Understand no? Is unnecessary task or not? No? So that's why we need to reduce the burden of the microprocessor. To avoid the burden of the microprocessor, so the non-vector come in the picture. Non-vector. What non-vector? Nothing but C. Non-vector is C now. What non-vector? Only one line. Then only for tell me one line. Multiple devices you can connect now, no problem. Device 1, device 2, device 3, and number of devices you can connect now. But only tell me one line. So what is the non-vector methodology? See, multiple devices communicate the microprocessor with a single interrupt line. With a single, the non-vector procedure only. What non-vector? Multiple devices communicate the single interrupt line. Single interrupt line. So because of this reason, no non-vector come into picture now. Non-vector. So multiple devices are there, but single interrupt line is there only. Only one line. Understood now? So only one line is there. Okay, the number of lines are, tell me, reducing. Pin size reducing, size of the IC reducing, but microprocessor burden also reducing one automatically. Okay, only one interrupt na. Microprocessor point only for what? One. Yeah, 10 devices or 30 or 40, whatever. The number of devices are there. Microprocessor point only for what? One. So automatically burden reducing only. So you can see how to convert the multiple line devices to single line, nothing but. So what happened here? People try to understand. Okay. These four interrupts, the vector, the four interrupts internally microprocessor contain the interrupt controller is there internally. It is there, one circuit is there internally. Interrupt controller is there, one circuit is there internally. Interrupt digital circuit only. Interrupt controller. This circuit responsibility, the circuit internally defined. This is a high priority. This is the least priority. The define internally the circuit on. And internally defined like this is a edge triggered, this is a level triggered. Everything internally, some circuit is there only. The circuit all predefined everything now internally. So we study the manual. Just now I told the trap is a level trigger also, edge trigger also. Nothing but internal system understanding or not. Your interrupt control digital circuit is there only. So the digital circuit is a 4 okay maintainable, but 30-40 is a complicated or not. Understood now? That's the reason. What is the circuit now? The same circuit we need here also. One circuit required only. One circuit required. That is a one IC actually. Okay. One external IC only. Okay. This is IC is called a programmable interrupt controller. Is a 8259. Programmable interrupt controller 8259. So it is also called a interrupt manager. Interrupt manager. It manages all interrupts only. So, two is a reduce the burden of the processor. Processor burden of who can reduce now? 8259. All the interrupts are first to come to 8259, not the microprocessor. First everything come to what? 8259. Okay. Understood now? You can see now device 1, device 2, device 3. 8259, it can handle at a time 8 interrupts only. How many? 8. Latest one, it can handle 128 interrupts. How many handle? Latest one. It's an old method, no? 8055. How many handle? Tell me. 8. 8 handle now. This one. Okay, now see. IRQ 0. Tell me. IRQ what? 1. Like that, tell me. IRQ 7. How many handle? 8. 8 devices, you can connect the 859 input only. So only one line now. See, only one line now. See, only one line. Only one line connected to the see, only one line. Only single line only. You understand? Single line. So this single line, everyone also pronounced like a, this single line is also called a, it's very important actually, shared interrupt line. They also called, tell me. Understand what is shared interrupt line? I should know. All the devices are communicated only for what? One line. That's why one more name also. Everyone called a shared interrupt line. Somebody asked the question, what is shared interrupt line? So the meaning of shared interrupt line, one line to communicate the multiple devices via programmable interrupt controller. Via who? Programmable interrupt controller. PIC. Programmable interrupt controller. Via. How PIC works now? We are going to study first how it works now. I think I told one signal. Everyone remember now? INT acknowledgement signal. These 4 interrupts, no acknowledgement or not? The 4 interrupt, no acknowledgement. Because they are vector interrupt only. Whenever this interrupt occur, microprocessor have clear information. No? They go and execute. No question at all. But whenever this interrupt occur, microprocessor question mark or not no. So no, here acknowledgement important now. Yeah, this saved interrupt line acknowledgement only, not for this one. Understood everyone? The acknowledgement for who? Only for what? Saved interrupt line. So why acknowledgement now? See now, clear. What the reason of acknowledgement? You can see. What is the reason of acknowledgement? See. So now I'm going to explain, okay, see clearly how non-vector interrupt works now. So if somebody asks a question, how interrupt works, explain the same steps only. Okay, how interrupt works now, okay, see. Whenever first step now, the starting step is the first to device raising a interrupt. Like my phone in the ring. Or otherwise now, keypad what tell me? Pressing on it. That triggering or not? No. Trigger. Now is that rise triggering or fall trigger on it. So the first to raising interrupt on. So whenever first to interrupt is coming to the 8259, first to device raising interrupt. Second step is the PIC responsibility. Okay, check the priority of the interrupt. Priority of the interrupt. Okay, maybe two interrupts occur same time also. The internally, the priority resolver circuit is there now. Internally is there circuit now. Priority resolver. Okay, the first one high priority, last one least priority, like that. Priority is there now. Check the what? Tell me priority. Based on the priority, two occur, then only single interrupt, no issue. Maybe multiple interrupt occur, based on the priority. High priority interrupt, first to second check the priority. Based on the priority, high priority interrupt send to the what? Send to the what? Microprocessor. Okay, the interrupt number not sending only, just triggering only. Just only for what? Trigger. Just triggering only. Microprocessor don't know about what type of interrupt only. Just only for what? Trigger. Okay, no, understood now. First to prepare the priority and to give the trigger. So now whenever microprocessor, the microprocessor execution some instruction, okay, some instruction execution, like here some execution. Suddenly interrupt occur. Suddenly what? Tell me, interrupt occur. Whenever suddenly interrupt occur, microprocessor actually interrupt occur in time some instruction execution only, some program execution, but microprocessor not handle the interrupt immediately. Okay, microprocessor it takes some time to it can take some time to complete execution of the instruction. Okay, for example, this instruction taken the 8 cycles only, 8 t-shirts only. The instruction how much time taken? 8 cycles only. But out of 8 cycles, okay, 8 cycles are there only. 8 cycles are there, instruction taken. 8 cycles are there. So exactly 4th time cycle, 4th period, here interrupt occur. So microprocessor runs some instruction. How much time taken? 8 cycles. But 4th clock pulse interrupt occur only. But microprocessor cannot handle only. Because already the middle of the instruction, whenever 8 completion, then only enter instruction close. Move A comma B. It taken a minimum 4 cycles. Minimum 4 cycles. How many? 4. 4 compulsory. Nobody can't stop the middle one. Interrupt occur, acceptable, okay, but the interrupt can handle after completion of the remaining one, 4. Remaining 4 now the microprocessor can analyzing, okay, now I am ready to handle what? Interrupt. So whenever microprocessor ready now, then give the what? Then give the what? Tell me. Then give the what? Acknowledgement. That is the purpose of acknowledgement only. So when the microprocessor gives the acknowledgement, whenever microprocessor is ready to handle the interrupt. When ready to handle the interrupt, complete the, tell me, complete the whole instruction. Correct? Entire instruction or no? Complete the remaining part, whatever. Complete the whole instruction cycle. Whole instruction cycle completing one. Whole. The entire instruction completing now. Wherever stop now, the remaining part actually. So complete the whole instruction cycle, then give the what? Tell me, acknowledgement on. So microprocessor raising the interrupt acknowledgement signal after complete execution of the instruction. Correct. After complete execution of the instruction. After complete execution of instruction. So microprocessor raising a acknowledgement after complete execution of the instruction. No pending the instruction on it. Then rising also. It takes some delay, but acceptable. Okay. Some the microsecond delay, something acceptable. So actually what happened, tell me previously what happened, vector interrupt. When a vector interrupt occur, previously also after complete execution only, any interrupt complete execution of the instruction only, but previously in the fixed memory location, microprocessor has the clear information. Previously one microprocessor was clear, go to vector table and handle only. But this one tell me non-vector. Microprocessor have confusion. Understood now? So microprocessor don't know where it can go. That's why give the acknowledgement to tell me. Fine. Why give the acknowledgement nothing? But microprocessor don't know. Okay, interrupt occur. Okay, I'm ready to handle. But which interrupt, where I can go, don't know. Tell me, understood now? Don't know path actually. Don't know what path. That's why give the acknowledgement only. So one is give the acknowledgement nothing but PS understanding. Okay, microprocessor ready to handle, but microprocessor don't know where it can go. Correct? So whenever the PS receive the acknowledgement signal, PSC now immediately send the which interrupt occur no? The interrupt address, vector address no? The interrupt vector address sent to the data bus. Sent to what? Data bus. Yeah, fifth one. So vector address no? Vector address no? Because the microprocessor don't know no? Where it can go, don't know. But who know about the address? Tell me, who know? PSC. Who know about PSC? The PSC now fifth step now, it can send the vector address to the tell me who? Microprocessor. So microprocessor now reach the vector address. Now microprocessor understand. Okay, I want to go here only. You can go now. That position. Understood everyone now? The 5 steps are there. Understood clear? So what the first step? Tell me. Starting step. First to divide raising a interrupt. Okay. So in the PSC verify priority. PS verify what now? Priority. Whenever high priority the interrupt occur, that only allow. That only for allow. Whenever receive the high priority interrupt, any interrupt, not only for non-vector, vector, any interrupt. If you receive any interrupt, no, after complete execution of the what? Instruction cycle. Okay, after complete execution of the instruction cycle, okay, it can send the what tell me? Interrupt acknowledgement. Acknowledgement signal. Okay, the acknowledgement signal indicate microprocessor ready to handle, but microprocessor don't know where it can go. Whenever acknowledgement is coming, PS understand. Okay, microprocessor understood, but microprocessor don't know which interrupt occur, what address only. Then immediately send the address to which bus? Data bus. Data bus. Okay, once you receive the address to microprocessor, now it can go also. But here some drawback is there. The drawback is that it takes some time, not immediately, but it's better because anyway a lot of advantages there because everything priority, all the responsibility taken by what? PSC, not a microprocessor. Microprocessor don't worry about anything. All the things are take care about the PSC one. Understood now? So microprocessor surrounding so many chips are available. Okay, is a one chip. Okay, programmable interrupt controller. So many are there. Okay, the programmable timer. So very important timer actually. Provide a delay our embedded system on it. Timer very important. Programmable timer, programmable interrupt controller, programmable keypad controller, programmable general purpose controller. Okay, so many are there. So many chips are there. No, around we see now that anytime no, you are the hardware kit. No? So many chips are there. ICs are there. Every IC is a one type of the interfacing IC. They are called what? Interfacing IC. They are supporting to the microprocessor. Supporting now. Okay, microprocessor main goal execution of an instruction. Any other thing requirement is there? They are supporting on. Interrupt this one. DMA is there. No. DMA 8237 or 8257. DMA separate chipset only. In short, yeah, you know, in short, no 8251. You know, universal synchronous, asynchronous what? Receiver and transmitter. You know, UART, yeah? UART you understand maybe. Okay, UART. Tell me 8251. Correct? 8259. What tell me? Programmable interrupt controller. 8253. Programmable timer. Programmable timer. Okay, 8257 or 8237 DMA. Okay, 8279 keyboard controller. 8279. There are so many are there. 8255 programmable peripheral interface. Very, very important. Programmable peripheral interface on 8255. Programmable peripheral interface on 8255. 8255 you can connect the LED, LED switches. The program the port A, port B, port C like that now. Okay, all LED switches now. The interface which would device 8255 LED or you want bright LED no. The LED is the device you interface the microprocessor where this one only. LED switches also. Switches the matrix keypad. No. Keyboard, no? Keyboard. Yeah, 4x5 matrix keypad, keyboard, no? They all very interfacing. A to 5.5. Stepper motor. Okay, no? Some motors, no? Very interface A to 5.5. Very important. No? A to 5.5. So they all the called interfacing ICs only. They all the names called to me interfacing. Interfacing ICs only. So all the list are given here, or maybe I will share the document also. You can see now even programmable IC is correct now. A259. Okay, what A259? Programmable interrupt controller. Just on today's study now. A259. Next what? A253. Programmable timer. A250. Inverse asynchronous receiver transmitter. A250 or 51 also. Oh, 50, 51. A279. Keyboard controller. A255. Programmable IO. Programmable interface. Okay. A237 or 57. Direct memory access now. The same thing is available now your latest laptop also, but chipset numbers are different. I'm sure your laptop also contain the PAC, but that is called APAC. That is called what? Advanced Programmable Interrupt Controller only. Your laptop contain. Same PAC is there. The laptop nowadays also. That is called what? APAC. Your processor is a Intel i3 or i5, i7, something is there. Here also interrupt control is there. Your laptop now. That is called what? APAC. Advanced Programmable Interrupt Controller. If you understood now. So the coming, whatever the technology is coming, maybe we are studying now today AI or ML or latest processor or whatever coming, 8085 is a lifelong important only. Because this kind of the basic foundation, no processor cannot provide, especially beginner only. This is 100% secret of the subject only. Whoever understand 8085, they are lifelong, they understand embedded system subject very clearly. They are enjoy the life. 100% I'm telling, guarantee. If you start work on any microcontroller, no, understand everything. Same concept only, same thing. But 8085 is a beautiful opportunity because the 8085 is a simple concept. No? The 8085, everything is study now. Don't miss anything. Everything you want to study, interrupt, everything now. Because everything is study now. For example, today we study maskable, non-maskable, vector, non-vector. Now we are going to go the microcontroller, same thing is there. Same thing is there, same concept. But another name. Concept same only. There are also maskable interrupt is there, vector interrupt is there. There are also same concept, latest processor, wherever the microprocessor, microcontroller, wherever, any our digital circuit, no, wherever, no, same concept is applicable. Understood now? Now the technology changes, whatever, the basic foundation, no, A for apple. Correct now? Yes, sir. Basic foundation, lifelong now. If this, for example, you don't know 8085, always stuck up now. Because the new something, it is their latest processor also, but directly you can study latest one is difficult to understand. Understand now? Now you study first to 8259. Lifelong remember, okay, how interrupt works, okay. Whatever the controller, okay, ARM also there. ARM processor also there. But ARM is called a GIC. General Interrupt Controller. General, that's a name different, purpose same only. Same non-vector interrupt only, same concept, same methodology. The name is different. Understand? That is the name different, okay? But GSC handle 128 interrupts. How many handle? 128 interrupts now. GSC handle. Your ARM processor, ARM. Tomorrow target board now. Your ARM processor. Tomorrow what is the RAN mini board? Kernel master defined our STM32 microcontroller board. It can handle 128 interrupts now. You have vector table also there. I'll show tomorrow our hardware board now. Tomorrow our hardware, I show interrupt vector table clearly. System interrupt. Every interrupt you can see practically. Today maybe your people are studying interrupt theoretically. But in the coming days we are see exactly how interrupt works practically we are seeing now. Okay. I will share this material. You can go through this one. Okay. And one more is a, yeah, you can, one more I'll give a small assignment, the small question. Okay. See, go to the Google, download A259 data sheet. Manual, okay, manual, okay. So download the A259 manual. It is available in the internet. You can download now. The A259, you don't see or the manual, okay. A259A, okay. Programmable interrupt controller. So programmable interrupt controller. how many number of the interrupts? No, 8 level priority controller. It can support the 8085 compatibility, 8085, 808 also, and 8086 also support now. Expandable to how many? Tell me. 64. It can support 8 only, but expansion possible. The meaning of expansion: master slave configuration. Master and slave. This 8259, one more 8259 only. First one 8, next also what? 8. The 8259 output connected to this one only. Like that, how many? Tell me. 8 jar. 8 can connect now. 8 jar 64. 64 now. Okay, master slave like that. Okay, one to other one like that. Interfacing also. Okay. So you can see everyone understand programmable what? Interrupt modes. Programmable interrupt modes on programmable. The programmatically you can decide this is a high priority, this is a less priority. Programmatically you can decide. The meaning of programmatically, they mention some registers only. Programmatically you can programmatically maskable, mask also. What mask? Enable or disable? Maskable interrupt. Non-vector which interrupt now? Maskable. Maskable. Okay, but where the maskable? Here only. PSC maskable on now. Not the microprocessor. The masking capability, who are there? PSC. Not the microprocessor. So you can see the block diagram of 8259. See now? The block diagram of 8259. So the 8259 output now is going to a microprocessor or not? Interrupt line. Yes or no? So the acknowledgement coming, acknowledgement I told no, interrupt acknowledgement no, low signal. Acknowledgement coming from what? Microprocessor. Understand? No? Interrupt rising and acknowledgement coming. These are coming to control logic of 8259 digital circuit only. Everyone see now? How many number of interrupts handle? Hello, the input or not? Yes or no? First step I told starting step 1. Step 1 yeah, 8 interrupt line 8 devices only. How many do they connect now? 8. Device 1 rising interrupt to IRQ 0. Yeah, input or not? No. First interrupt occur here only. First starting step only. Yeah, now interrupt here. Interrupt request register. Here identify which interrupt occur and check the what priority. Yeah, for example, 2 occur, 3 occur, priority, and go to what? Interrupt service register. Here maintain the information finally which interrupt occur. The maskable register also. Enable or disable. Programmer controlling also here. I told you bit number 0 enable, first interrupt enable. Bit number 1, second interrupt enable. Bit number 2, third interrupt enable. Understood now? Maskable. Every bit on there. Maskable. Maskable and service register. Okay. So now finally the interrupt finally occur to wait a minute, microprocessor no? Based on priority. Next coming what? Acknowledgement on. Once acknowledgement coming, the vector address transfer to the, tell me, data bus or not? No. Yesterday I told you these are bus actually. You don't the all things are bus or not? Hello. The bus is a common to everyone and internally. That's why we are the tri-stage buffer or not? No. You can see there are many registers are there, no? The IFR register, ISR register, all registers are not no. The communicate the one register to other register via the bus are not no. The bus now, the bus diagrams no. The bus diagram we have internally the read bar, write bar is there. Which register to read, which register to write, the bus no internal no. Bar, write bar, okay? No, because here contain the registers no. Yes or no? Maskable register. If any register you want reading, writing also, they are control lines only. Read bar, write bar. Okay, which one you are reading only. Okay. CS bar is a enable enter chip or not. Every IC how common is there. Okay, first enable the chip enabling or disabling one. Okay, so these lines are useful for cascade no, cascade no. So you want cascade to n number of the cascade one no. First to PSC one, connect the next to PSC two. Next cascade no, how many cascade no? 8. Okay, 8 nothing but you can see 3 bits no. 3 bits, how many combination? 8. 8 combination, okay. Cascade lines are useful to connect the 8. 000 is the first one. Next one what? 001. Next one what? 010. Understand? No? Cascade mode. This circuit support the what? No? Cascade mode. You know that cascade mode no? D flip-flop 1 output connect the second flip-flop input. No cascade mode or not? No. Okay, that pin diagram explain detailed information. You explain clear now. The polling method and the interrupt method actually. See interrupt method no? Interrupt method. So which interrupt occur you can see here explain clear. See no? So you can see device 1, device 2, device 3. Observe her. The device rising interrupt go to where first to PSC. PS rising interrupt to where tell me interrupt. Correct no? Both are communication via tell me data bus. You are explain no? The exactly how the interrupt handling works now. Today assignment is write down how non-vector interrupt works. Okay, a step-by-step procedure is there. We can read and write down. Okay, this is the answer one. Interrupt sequence one. So how non-vector interrupt works? Okay, the answer here only. Okay, step-by-step write down sequence also. These are sequence now. 7 steps are there. Write down. Okay, how non-vector interrupts works. Download this manual from the internet. Okay, the answer here on now. Answer. Whatever explain now, all the steps are there. I told you step 1, step 2, na? Step 1, step 2, step 3, step 4. All the steps now, your answer is there on now. Okay, again step 1. You know step 1 na? What is step 1? Interrupt request. Okay, and send to tell me CPU. Next step CPU give what tell me? Acknowledgement. So once acknowledgement is a receiving. Okay, next to acknowledgement receiving, next to call instruction. Not directly vector address only. Because call instruction is a invoke the subroutine. Invoke the simple. No, don't confuse anything. Okay. Right now, I'm the main context or not. I'm explaining the class now. I'm about main context. I'm main context to interrupt context. How to move one context to another context? Because I'm the human, I know the sound ringing. Okay, definitely I can go and accepting. Okay, jumping. But microprocessor, how you can understand? Okay, move to one context to what? Another context. Like one function to another function. How we move nothing but if you whenever moving one context to another context, microprocessor should know the other context address and the context address. And you can move one context to another context. Backend contain the call instruction. Which instruction? Call. Call instruction is called a branch instruction. It can change the sequence of program one location to another location. If you understand now. Very important. Tomorrow I'll show the demonstration. Tomorrow. Call instruction is a very, very important to know words actually. If you understand the call instruction, everything you can understand now. No words. Call, return, push, pop. Very important actually now. Your lifelong. So actually, no, so many questions answer is there only. So many questions actually. How the computer works now. So many questions answer is there. Call, return, programmatically, programmer no. The backend, how the things running. The answer, most of the answers are call, return, push, pop. The beautiful instructions. So now we'll see this tomorrow. Call instruction compulsory. We will explain tomorrow. Understood? Okay. Call instruction first to send it. Next to acknowledgement is given only. Okay. The job simple actually. Let's see actually what happened. I'll show you. Understanding. I can't store here. So, are able to see my screen, everyone? Hello?
Yes, sir.
Yes, sir.
Yeah, now see what happened actually. So, what is the data bus width? Width of the data bus 8 bits. 8085 microprocessor. What data bus width? Tell me 8 bits only. Okay. So, actually, you know the memory address, no? The memory range of 8085 microprocessor is 4 zeros to 4 Fs only. 4 zeros to, tell me right or wrong? Because why 4 zeros to 4 Fs? The memory range of 8085 microprocessor is, tell me, 4 zeros to what? 4 Fs. 4 zeros to 4 Fs something. But tell me, approximately what time is 64 kilo. No. So the decoder input now. What decoder input? Hello. What decoder input? 16. What decoder input? 16 line. So that 8085 microprocessor have how many address line? 16. What is the depth of the memory? 64 kilo. Okay. The memory range of 64 kilo. That's right, Torna. The memory range of 64 kilo is, tell me, 4 zeros to 4 Fs. 4 zeros to what? 4 Fs. No. So compulsory the minimum 4 hexadecimal digits. No. Minimum how many? 4. Nothing but the binary point of view 16 bits. Binary point of tell me 16 bits. So memory address is 16 bits now. Okay. Call instruction is there now. Call instruction is 8 bit only. Total how many number of bytes? Total how many number of bytes? Tell me. Hello. Bytes I'm asking. How many number of bytes? Tell me. 3 bytes. 1 byte equal to how many bits? 3 bits. Okay. 8 plus 16, 24. 24 bits. How many bytes? Understand now? Total how many bytes? Tell me. 3 bytes. 1 byte is a call instruction. The information. Call instruction or not? No. The instruction also some the opcode is there. No. The mnemonic. Call. Microprocessor understand the call, no? Call is a some 1 byte is there, 1 byte. Remaining 2 bytes are what? Tell me. Address. Total how many sites? Tell me. 3 bytes. So now, but actually the bus width 8 bits. That's the reason what happened. But whenever first acknowledgement is coming, it can transfer the call only. Transfer the what? Tell me. Call. It cannot transfer the 3 bytes at a time. Understood? No. 3 bytes at a time, because the road is very small, only bike only. Understood? Road what? No, understood? You can't transfer what? 3 bytes only. Transfer the only for what? First byte. First byte what? Call transfer only. So once call receiving microprocessor, generate the second acknowledgement. Generate second, one more acknowledgement is coming because requirement is not fulfilled. Generate second acknowledgement. When the second acknowledgement coming, second time transfer the second byte. Second time transfer the, but still requirement not fulfilled. Generate one more acknowledgement, transfer the what? Third byte. Like that, how many acknowledgement? 3. Because 3 bytes now, every byte on acknowledgement. After 3 acknowledgements now, finally you can receive the 3 bytes only. After 3 byte receiving, now microprocessor have clear information where you can jump. Understood now? That jump to that location, wherever the jump. Call, address. Okay. Tomorrow we'll discuss call. Maybe you didn't understand, don't worry. Tomorrow we'll discuss the call. You can understand also. Call is a change the routine. Change the what? Routine. Okay. Change the routine. Okay. How to move? Like a simple call instruction. Okay. So on the human, I can able to move this context to tell me directly phone context. But computer, how to move the one context to another context? The answer is a call. The answer is a call. But how call move one context to another context? No. One function to another function, you'll see tomorrow session. You understand now? So now 7 or 6 steps are there only, but lifelong important, those steps only. It's not a simple assignment. Anybody has the question how interrupt works, you can always explain the non-vector interrupt only. Okay, how many steps are there? 7. The manual download and remember, draw the block diagram, lifelong, always the very beautiful 8259. You want to study, okay, 8259. They mention also polling method, interrupt method. The data set is the best documentation. Embedded software developer, best documentation what? Data sheet. The data sheet manual, everything clearly mentioned now. No more, not more than that. Actually start the digital electronics also or not. So a lot of the block diagram, so much information, but everything not required, but information is important. Understood? No? That information we can't find it anywhere also. Okay, if you read some textbooks also, some internet also, but everywhere explain generic only, general thing. But perfect information is getting from the data sheet only. Exact information. How the things running and everything, you'll find out. Okay. So that is a today assignment you can do, everyone.